the previous page, 5 through 12, I'm using this picture. So if I look at number 11, it says the measure of angle 2. And I always mark it acute because it's a small angle. And the measure of angle 8, those are acute in case you're wanting to know they're alternate interior angles. But if they're both acute, I'm going to set them equal to each other. So acute equals acute. It's 12x equals, and then I'm going to set it equal to 8x plus 16. I'm going to subtract 8x, and I get 12x minus 8x is 4x equals 16. I'm going to divide by 4 on both sides, and I get x equals 4. The question asked me to find the measure of angle 6. The measure of angle 6 is a vertical angle with 8. So I'm going to plug it back into either one of these, it doesn't matter. But this is 12x, so 12 times 4. Are you looking for the extra worksheets? They're on the podium. 12 times 4 is 48 degrees. So number 11 is 48 degrees. I don't have any more then. We'll just have to get some off the internet. Give me a second. Let me finish this video. All right, number 5 is an obtuse angle, and number 4 is an acute angle. They're different, so you're going to do O plus A equals 180. O is 14x plus 12, and A is 6x minus 2 equals 180. Combine like terms, I get 14 and 6 is 20x, and 12 minus 2 is 10 equals 180. Subtract 10 from both sides, I get 20x equals 170. Divide by 20, and that gives me 8.5. It says find the measure of angle 6. So 6 is an acute angle, so I'm going to plug it into the acute. So that's 6 times 8.5 minus 2. 6 times 8.5 is 51, minus 2 is 49 degrees. So number 12 is 49 degrees. All right, 13 says define preimage. It's the original. It's what you start with. It's labeled A prime, B prime, C, or I'm sorry, it's labeled A, B, and C. The image is what you finish. Finished figure. It's the one that's labeled A prime, B prime, C prime. An isometric or rigid transformation, it is the same shape and size. In other words, all measurements stay the same. The angle measurements stay the same, length, volume, surface area, anything like that stays the same. So that's what the pre-image and the image, it just moves around, but nothing as far as measurements change. There are 3 rigid or isometric transformations: reflections, rotations, and translations. All right, this one says draw a coordinate plane. So it tells you to label the x-axis. It tells you to label the y-axis. It tells you to label the quadrants, and they go counterclockwise. 1, 2, here's quadrant 3, and here's quadrant 4. So 1, 2, 3, 4. It tells you to plot and label points. Ordered pair is 1, 2, 1, 2, 3. It tells you to label 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's B. And C is 1, 2, 3, 4, 5, 6, 7, 1. So that's your pre-image. It's what you started with. Okay? And then it says plot the pairs, connect the points, perform the following translations, and label each appropriately. It does say go 10 units in all directions. I'm not going to number that right now just for time. Number 16 says reflect over the y-axis. So my y-axis is here. Reflection means if this is the line of reflection, if it's 2 this way, it's 2 that way. So if it's 1, 2 to the line of reflection, it's 1, 2 away. So that makes this A prime. The ordered pair is 2, negative 2, positive 3. And then this is B, and it's 1, 2, 3, 4, 5 away. So it means it's 1, 2, 3, 4, 5 away. So that's B prime. Its ordered pair is -5, +5. And then C prime is 7 away, so here's 0, here's 1, 2, 3, 4, 5, 6, 7. So that's C prime. So that was number 16. So this figure, resulting figure, is 16. And then 17, it says after the reflection, translate the figure x plus 2, y plus 3. So that means every point I go over 2, and I'm sorry, y minus 3, so down 3. So that puts A double prime at 0, 0. And then 1, 2, and then 1, 2, 3. So B double prime, that's -3, +2. And then C is 1, 2, and then 1, 2, 3. So that puts it at -1, 2, 3, 4, 5, -2. 5, sorry, -5, -2. Notice all of the, I'm not being super accurate with my drawing of my lines, but the shapes are the same shape and size. None of the area changes. So that's number 17. And then it says after the translation, rotate the figure counterclockwise 90 degrees. And I always assume it's around the origin unless it tells us. The A prime, A double prime is around the origin, so it doesn't change, but a 90-degree clockwise turn, I guess I need to trace my figure first. So that's B, and this is C. And so a 90 degrees clockwise turn puts B here and C here. So that's C, and it's 4 primes, right? And that is 2, -5. And B is B 4 primes or 3 primes. I think it was 3 primes, sorry. And it is -2, +3. And so that would be my rotation. That's number 18. It says you should have 4 figures shown on your coordinate plane. So here's 1, 2, 3, 4. My pre-image, my first, my second, and my third. Sorry, that should have 3 primes. I think I had 4. Forgive me. And then 19 says if you reflect across x equals -1, so x equals -1 is this line right here. And so it wants to know what's the coordinate of B prime. Well, if I'm reflecting, this is 1, 2, 3, 4, 5 from the line of reflection. So it's going to be 1, 2, 3, 4, and it goes over. That's okay. It's going to be 5 from the line of reflection. And what is that ordered pair? So remember, this is our line of reflection. It's not 0, 0. So here's 1, 2, 3, 4, 5, 6. So that's -6, -1 is my ordered pair on 19. Sarah is creating a model of Jefferson Memorial. The Jefferson has a height of 350 and it has a width of 75 meters. Okay, it says his model will have a width of 15 centimeters. Okay, centimeters. So meters and centimeters, this is width and this is width, and then it says what will the height be, and that's where my x is. The 350 and the x are my height. I cross multiply and I get 75 times x, which is 75x. And I get 350 times 15. And if somebody will do that really quickly for me, I believe it's 5250, but check on that for me. So if you'll multiply 350 times 15. Is it 5250?
Yes.
And then I divide by 75, and I get x is 70. So, and it's centimeters. Number 21 has an A, B, C, and then there's a D and E and F on the next page. This is the 5 congruence theorems at work, and remember there are 2 that don't work. There's the AAA battery, and then there's the bad word. We're not going to spell it the correct way, but remember those don't work. Side, 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 so it's 3 sides that are marked, a side with an angle between the sides, 2 angles with the side between, 2 angles with the side not between, and this is hypotenuse leg. It has to have a 90 degree and it has to have 2 legs marked. One of them is the hypotenuse and one of them is the right angle. So if we look at A, we have 1 angle, 2 angle, 3 angles. So 3 angles that are marked don't work. So this cannot be determined. It may be, but we can't be determined with knowing only 3 parts. This has 2 parts marked. It has an angle and a side, but we can also go ahead and assume that vertical angle. And if you look at that, it's an angle, side, angle. It's a side between 2 angles, so it's side, angle, it's an angle and 2 sides. So it's angle, side, angle. I said that wrong again, sorry. It's 2 angles with the side between them. So here are my 2 angles and the side that connects them. This is a reflexive side, so it can be assumed, and this means 1 side, 2 sides, 3 sides. So that is side, side, side. And I'm going to go ahead and on this video, I'm going to finish, if I can find it, I'm going to finish D, E, and F. D is angle, side, angle. E is side, angle, side. That's the only one with 2 sides that work is when the angle's between them. And this is angle, angle, side. Not the bad word. It's 2 angles and the side not between them. Both of the 2 angles with a side work. It's just where is the side? This one's between, and this side that is common is not between the 2 angles. Does that make sense? All right.